Administrators at your school want to estimate how much time students spend on homework on average during a typical week. They want to estimate mu at the 90% confidence level with a margin of error of at most 30 minutes. A pilot study indicates that the standard deviation of time spent on homework per week is about 1.54 minutes. How many students need to be surveyed to meet the administrator's goal? Okay, so your margin of error, we're going to use Z in this case since the population standard deviation is sort of known. We're going to use this standing value. And as you read in the notes, or we talked about in class, when the sample size is large, the difference between your Z critical value and your T critical value is very, very close. So we're going to use our sigma. So that's this 1.5. I'm sorry, this 154 minutes. Let me highlight that. So this 154 minutes, the standard deviation is going to be our sigma. Our goal is to find n, and they said our margin of error, they want it to be at most 30 minutes. So notice that's not a proportion anymore. It's has the units of what you're measuring, so time. So 30 equals, now this Z critical value for a 90% confidence interval, 1.645. You can get that with the table. I like to get it from the T table and just go down to degrees of freedom infinity, 90% confidence. Or you can do inverse T of 5% because there's 5% in the tails. And you're going to solve for n. So what are you going to do? You can cross multiply, like bring this root n over here and divide by 30. Or like multiply both sides by root n, then divide by 30. And then square everything. So that last step should be squaring. And you get n is 71.21, so always round up. So we would want to get at least 72 students. If you got more, your margin of error would decrease. And they said at most 30 minutes, so 72 or more. How many students would need to be surveyed? So 72. All right, let's look at this next one to reveal a little bit at a time. So this totally different problem. Biologists study the healing of skin wounds measure the rate at which new cells closed a cut made in the skin of an anesthetized newt. Wow, very specific. Here are data from a random sample of 18 newts measured in micrometers per hour. Calculate and interpret a 95% confidence interval for the mean healing rate mu. So this is a 4-step process problem. State, plan, execute, conclude. It just says calculate and interpret, and you need to know everything that needs to be shown. So in our state, we need to define the parameter. So mu is the true mean healing rate. And you need to state the confidence level. So at a 95% confidence level. Now we'll move on to the plan. We'll say what the name of the test is, or what we're doing. It's a one sample T interval for mu. And then we'll check our conditions, which is random, the 10%, and the normal condition. So random, they said it's a random sample of 18. Check. 10%. So we do that random so we can generalize to the population of all newts. 10%, 18 is less than 1/10 of all newts. So we can use that standard error formula and sufficient independence, even though we're sampling without replacement. Normal. Now, we don't know anything about the population distribution. They didn't say anything about that shape. Our sample's not bigger than 30. We can't use the central limit theorem, but you can graph the sample data. And yes, you need to graph it. You need to provide the picture of the sample data. So that's these values, the 18 newts measured in micrometers right here. You can do it with the calculator. You can just make a quick dot plot. No strong skew or outliers in the sample. And that's what you're looking for to continue on, to pass the normal condition. We see this, so okay, the sampling distribution of sample means will most likely be approximately normal. All right, so let's execute. Let's actually calculate our confidence interval. So put it in general. It's a point estimate plus or minus a margin of error. Let's put the specific formula our sample mean, x bar, plus or minus a t critical value times the standard error. S sub x, our sample standard deviation divided by the square root of n. And plug those values in. Okay, so this t critical value, 2.110. So the degrees of freedom is, since the sample is 18, the degrees of freedom is 17. With a confidence of 95%. Did they say 95%? They didn't say. That's just what we're going to do. Yeah. Oh, they did say 95%. 8.32 divided by the square root of 18. You get this interval, the upper bound, the lower bound. And your conclusion, we are 95% confident that the interval from 21.53 to 29.81 micrometers, check out those units, per hour captures the true mean healing rate. Always provide context. So you must do this 4-step process on every homework problem marked 4-step process for credit. Oh, and on the AP too, and on our tests, of course. So that's everything you need to do. Write out SPEC. It'll help you remember what's in each step.